Okay, this is geometry, lesson 4, part 1, and we're going to look at example 4. An asymmetrical roof on a shed has sections that are 18 feet long, right here, 14 feet long, down here, and then the roof has a rise of 6 feet. And for both of these questions, I'm going to answer it on this page. I know the solution is on the other side, but I want you to be able to look at this as we solve it. So the first part is, how wide is the building? Okay, so from D, the corner, all the way to B. Now, based on what we've been given, and I added some labels here. So we got a hypotenuse of 14. Opposite of the angle is 6 feet. We don't know from C to D. Over here on this side of the roof, we know the side length of 6, hypotenuse of 18, because this is also a right angle triangle, and we don't know the bottom. Now, if we could find both of these bottom pieces and add them up, we should be able to get from B to D. So, how could we do this? Well, there's a number of ways. We could use Pythagorean theorem to get this one. You could just solve for one of the sides. We could also use one of the ratios, like tan or cosine, because we have opposite, hypotenuse, and an unknown adjacent. So I'm going to use cosine. Now, like I said, you could pick whatever one you want as long as it works. So remember, it's adjacent over hypotenuse. And we have the angle, we have hypotenuse, or sorry, we have, hypotenuse 14, and adjacent will be x. So down here, I'm going to go cosine 25 equals, now instead of adjacent, I'm going to go x, because that's the piece we're looking for, and the hypotenuse of 14. And then to solve from here, it should be one step. I'm just going to multiply by 14 on both sides. Okay, so multiply by 14, 14 over here, and that's gone. And now I have x equals 14 times cosine 25. So 14 cosine 25, and make sure your calculator is in degree mode, and you should be able to punch that in. So we got 14 cosine 25. And I got 12.68831. So I'm just going to take 5 decimals, and that is in feet. Okay. Now, if you use tan, you're going to get a slightly different decimal number, which is fine, because at the end, when we round, it should come out to the same answer. If you use the Pythagorean theorem, so if you solve for a side length, I believe, let's see what it comes out to. Relatively close to the same thing, but you're going to get a different decimal, but that's okay. So make sure you take 5, and it'll make up for that difference. Okay, now number 2, or step 2. So just going to rewrite this here. So this is step 1. Okay, number 2, to find from B to D, we're going to go, oh, sorry, B to C, not B to D. We're going to use Pythagorean theorem because we don't have any of the angles to use any of the SOHCAHTOA fractions. So x is a side length. So we're going to use this equation. So take the hypotenuse, square it, subtract it from the other side that you do have, and square root. Okay, so I'm going to replace s with x. And then our hypotenuse is 18 minus 6 square root. And if we crunch that number, we'll get 16.97056. Okay, and I took 5 decimals, and that's feet. Okay, now step 3, we have both of the x's that we need. We're going to add them up to get the length, which was our ultimate goal. How wide is the building? So if we add these up, 12.68831 plus 16.97056. So from B to D. Plus 16.97056. We end up with 29.7 feet. Okay. Now remember, if you use one of the other ways and it comes out to, I believe it might come out to 29.8, that is fine. Okay, I will know that. So on your assignment, don't worry. All right, now B. And I'm just going to do B up here. Classify triangle ABC. So from here to B to C by angle and side length. So triangle A, B, C. It's a right angle triangle. And by side length, none of the sides are the same, right? 6, and then 16.97 and 18. That makes it scalene. So if they're all different lengths, scalene. Triangle A, C, and D. So that's from A to C over to D. We also have a right angle triangle. And the sides are all different lengths, so scalene. Okay. And then triangle ABD. So the whole thing. So from A to B all the way over to D. Okay, this is not a right angle triangle. It is not acute. Okay, we do have angles less than 90 here and here, but this big angle up at the top, angle A, all the way across, is greater than 90. So this is what we call obtuse. And then none of these side lengths are the same. Okay, so we got 29.7, 14, 18. This is scalene. Okay, and if you want to take a look at the solution on the second page here, you can, and you're going to see that their shed width comes out to 29.6. That's because they use Pythagorean theorem the whole way. Okay, so I chose to do the first step using cosine, but you could use Pythagorean theorem here as well. And you would just solve for the unknown side. But again, it's coming out to relatively the same thing. So if you use Pythagorean theorem for step 1, you get 29.6. If you use cosine, you get 29.7. And if you use tan, you get 29.8. All would be acceptable answers. Okay. That is the end of geometry lesson 4, part 1.